With this chapter, we leave the planet and look at objects that make it clear how tiny a rock our Earth is on the scale of the universe. You've probably seen images like this one, or even made models of the solar system in elementary school. Even though we acknowledge that the objects are not scaled accurately, the images still commonly have orbits shown as rings on a flat disk. Well, in reality, it's not traveling on a disk, and the gaps between orbits should not be evenly spaced. However, the real motion is even more complex, because our solar system is moving through our galaxy. Even within this short video clip, it's not complex enough, because our galaxy is also moving within the universe. Let's return to just our solar system. The nebular hypothesis for the formation of our solar system is an old idea, and the most commonly accepted modern idea is more completely known as the solar nebular disk model. Within this model, a rotating mass of mainly gases collapsed by gravity to form a proto-sun. The spinning resulted in most of the heavier elements in the center, and eventually an overall flattening. The hot materials condense into icy, rocky matter, which were then packed together by the process of accretion to form planetesimals. These planetesimals form the planets you know, but they form a little bit differently. The inner planets were, and still are, warmer due to the proximity to the sun. They also lost much of their lighter elements due to the solar wind. The outer planets also retained some of their heavier elements, as shown by the yellow centers, but their massive sizes also allowed enough gravity to keep some of the light gases. Most of those are lost on the inner planets. The collisions that built the planets are still happening, but much less frequently now that most of the pieces are accreted together and the major pieces, Sun and planets, sweep out orbits and have removed most potential collisions. One of the most intense collisions to happen in our solar system formed our moon. In Earth's early history, while it was still forming and still cooling, a rock the size of Mars hit us. Massive amounts of Earth's mantle were ejected, and then accreted over time in much the same way as the formation of the Earth. This is how our moon is so large compared to Earth. However, the moon is not large enough to have gravity to hold on to any significant amount of atmosphere. There are various other bits and pieces to our solar system. Most asteroids order between Mars and Jupiter, but some do cross the path of Earth on occasion. Historically, the definition of asteroids, used to distinguish them from other leftover pieces from the solar system's formation called comets, included the presence of water and other ices solely on comets. However, water has now been found on asteroids. In general, asteroids have orbits that resemble that of planets, while comets reach far beyond, into the depths of the solar system. Specifically, comets reach into the Kuiper Belt or even the Oort cloud. The Kuiper Belt includes the most famous dwarf planet, Pluto, and extends out of the disk shape outside the planets. The Oort cloud is much farther out and extends in all directions. However, comets from there rarely make it to the inner part of the solar system. Regardless of the size or origin of a rock hitting the surface of the Earth, it is then called a meteorite.